Well, good afternoon, everyone, and thank you very much, Marielle, for the introduction. My name is Thibaud van Rooden. I'm working at Pôle MecaTech, cluster in mechanical engineering based in Wallonia, Belgium. I have the honor to guide you through the award ceremony of this IoT4Industry Video Contest. Let me tell you a few words about why we decided to organize a contest between a video in the first place. We had over more than 40 projects. Marielle told about it, and the idea that it was that this contest was a way to give them additional support first of all, but it was also an incentive to push people not to forget to communicate about the excellence of their solution. The rules were quite simple. Each participant had to realize a video of maximum 120 seconds. The video had to demonstrate the innovativeness of the project, and also the link with the IoT4Industry thematic and its scope, and also the sustainability. The reward was quite straightforward. It's a prize, 5,000 euros for the winner, 3,000 euros for the project ending second place, and 2,000 euros for the project ending on the third place. Now, before jumping through the three finalists, we received over 14 different videos that were submitted. You can find all these videos on simply on YouTube. Our partners from MTSC, our German partners, did put them online. You just simply have to type in project IoT4Industry in the search and you find them. Watch out, it's project with a K. So let's move on now to the finalists of this contest. And the three finalists are in alphabetical order: equality, MecaTech IoT, and Sense4Com. So we're now going to go through the three videos, and shortly after, we're going to discover the final ranking. Let's go for the videos.
The Equality Project is composed of three companies: Verhert, Lisaplast and Hopoo. The goal of the Equality Project is the creation of an agile system to predict the non-safe zones for pregnant and nursing women in the production plants based on ICT's technologies. The Equality Project makes use of IoT devices for real-time air quality monitoring called Smart Spot, provided by Hopoo. These devices include volatile organic compounds. Lisaplast, as a production plant, has been the testing environment. Equality has installed smart spots in different zones of the plant to collect the data. These data are analyzed through a software platform based on Grafana, an open-source technology that allows to analyze all the data to obtain conclusions and export them to other tools and to create reports. Verhert has been the company which has worked with the data, building diffusion physics model with a set of parameters optimized using big data analysis methods. To improve the user experience of the foreman and make easy the detection of dangerous areas for the pregnant and nursing woman, Verhert has developed an app called Emission Predict Equality. It allows the prediction of harmful areas related to the VOC emissions, CO and particles matter concentration in a heat map visualization of the production plant depending on the kind of extruded material. The exploitation of the results is linked to the commercial activity of each of the three companies that make up the consortium. Lisaplast is exploiting the results of its work-life balance programs for nursing and pregnant women. Lisaplast has been able to deliver to each work the EPIS adapted for its work position, and it allows to adapt the work zones to reduce the impact of harmful zones for all the workers too. Verhert has generated know-how that open new opportunities to develop similar tools for other production processes as a new service. Hopoo has increased its annual turnover by 15%, setting a precedent in sales and projects with industrial customers, which helps diversification.
Carbon dioxide emissions. This is the main cause of global warming. Each industry needs to chip in. Aerospace is no different. Fuel reduction is a top priority. One opportunity is to make the airplanes lighter. How do we do it? Using a mixture of glass fibers and resin, we create a composite material which is light, strong and durable, an ideal material for airplanes. But is this material safe? How can we test it? This is where the Sense4Com project comes in. The idea is to use optical fibers. If we embedded them inside the composite materials, we can monitor the quality of the composite during production and when the composite is part of the plane. A complete solution for quality control and safety, from cradle to grave. What are we developing? We activate the optical fiber with UV light. The light is creating a pattern inside the fiber, and this pattern is sensitive to temperature, pressure, and strain. Embedded in the composite, this allows complete control of the production. But that's not all. We need to read out the response of the fiber sensors. We need high-speed readout unit to detect possible cracks. Sense4Com is developing a unique solution, low-cost, miniaturized and extremely fast detection unit, able to detect the response of 8 sensors in one fiber, all in the same time. The next time you are boarding an airplane, take a moment to look around, and perhaps you will see some composite panels lighting up, giving you a safe feeling. World, here we come!
Okay, so without any further notice, let's jump now to the final ranking between the projects, and I will start with the third place, the bronze medal if you like. Now the bronze, or the third place, goes to MecaTech IoT. MecaTech IoT, congratulations, that's a French project led by Savoie Transmission. It's an application turn milling. The video is it's an excellent video, very much oriented toward the customer. Great effort, congratulations guys for this video. Now let's move on now to the second place, and the second place is going to Sense4Com. So that's a Walloon-led project. Congratulations to BSense, which is the leader of this project. BSense. Congratulations to Christophe and his team. Congratulations to Somnai, your Dutch partners in that regard. That's a very interesting project, an application of brake fiber in the aerospace at Sonaca. So great job, guys. You have the second place of this contest. And of course, the winner, that's the last project of the list. That's another Belgian-led project. It's Equality. It's led by Verhard with an implementation in a Spanish factory. It's also a very interesting project, interesting application, which is showing how you can tackle a societal issue at work with technology. So that's it. Congratulations to the three projects. Congratulations to the winner, Equality. I'm not going to go into more details about those projects because my colleague Alessia is going to take over and to go in a dialogue with these projects and to tell you all about them. But before I leave her the floor, I just want to tell you that there's a second session today about IoT4Industry in about a bit more than an hour, where you're gonna have the opportunity to hear more about IoT4Industry project. Other project leaders are going to give a testimonial about what they did, and there's also a presentation of EU funding opportunities with a representative from the Commission. That's it from my side. Congratulations once again to the 3 projects. And Alessia, the floor is yours. Alessia, I leave you the floor. Thank you very much for your attention.
Thank you, Thibaud. Hello, everybody, and welcome in the IoT4Industry digital experience. My name is Alessia Mindoni of Mesa Innovation Cluster, that is an Italian cluster located in Turin and focused on smart product and smart manufacturing. As anticipated by Thibaud, we will go through the IoT4Industry Video Contest winners to better understand how those solutions have been implemented into manufacturing. We basically realized 2 interviews, and what you will see is a very short, very condensed version, and then we will see a demo realized by Sense4Com. I give immediately the floor to the first project called MecaTech IoT and presented by Pierre Aguaro of Savaille Transmission.
Thank you, Alessia. In a nutshell, the project is about a predictive maintenance device. It's a small sensor that we can put on a machine, whatever the machine is, to check the behavior of the machine itself. This sensor is measuring temperature, hygrometry, atmospheric pressure, as well as 3-axis magnetic field, vibration, and shock. This is reported into a dashboard, which is accessible for everybody with a password, etc., which is really protected. The user gets periodic report, and based on threshold, he can receive alert. If we have a deviation by 20%, I'm sending you an email saying you should go to visit your motors or your machine because something happening over there. With this dashboard, we have a little bit some artificial intelligence with a 7 days prediction. So we have a tendency of the 7 coming days in order to see if you have chance to reach one of the thresholds. The other thing is, which is done post measurement, is a correlation analysis. So the added value, as I said, is planned instead of breakdown, event identification and corrective action instead of premature obsolescence. Then you can use as well the sensor in order to check the condition of use. Because some of time you have certain condition of use. For CMP, for instance, it is really important that temperature and hygrometry are respected. Last but not least, you can plan your maintenance based on the curves. You can imagine when you will have a problem, and you can manage easily your maintenance with no emergency. Just to show you a little bit of how it works, and that's a machine on the right. You have a atmospheric plasma machinery, which treat some pieces for the industry, so watches industry. And one of the difficulty we had is you have other machine running and working around. So the first video shows you that the noise around, because you have machine here and elsewhere that are doing some work. So I don't know if you see on the right, but you have a signal.
Yes, it's something.
Yeah. Okay. Perhaps it's too small. And
Yeah.
here you have the machine that works. It's really a tiny vibration, but the signal is really different. So you have on the right the signal, the original signal, and on the left the signal that we have seen together. So here the sensor detects that the machine is running. That's time to do a measurement.
Yeah, thank you very much for your time, and thank you for sharing with us your interesting solution. See you, bye-bye.
Thank you, Alicia, bye-bye.
Welcome back in the IoT4Industry digital experience. It's a big pleasure for me to present a quality project. It is the result of a Spanish-Belgian cooperation, and in particular between three companies that are Verhert, Hoopoe, Ubiquitous, and Besenplast. And the project focused on gas monitoring in critical environments. I give immediately the floor to Emmanuel, Jan, and Iris to better understand what quality is.
Our goal it has been to try to monitor in a factory environment, more specific in an extrusion company, the quality of the air to be able to adapt the schedule from pregnant women or women who are were just giving birth and still giving breastfeeding. Maybe I have to specify that there is European legislations of how many concentrations of every volatile or organic component. But for pregnant women, the concentrations are even lower. So we have to be even more careful. We introduced in the smart spots a new sensor, and this sensor is measuring VOX of volatile organic components. With all this data that we could measure in the production area, then my colleague Jan was bundling all the data.
Well, I would like to specify that what is interesting is that through the big data approach, it was possible to make this prediction based on inference to infer the pollutant production of each of these machines without having to stop and individually test them. We developed an implicit model for the diffusion problem, which was very interesting to do, and it's also very interesting because it's very generally applicable to other problems. Any diffusion problem, whether it is in air, in liquids, whether it's a diffusion problem in an industrial setting, in a factory.
Next question is the market opportunities you see, and if you are planning to go on market.
In general, we can add it because equality opened for us for open new opportunities, and now we continue working with the sensors in the factory because we are connecting directly the data in real time via blockchain connection with illustrious institutions, and we are working with the official body of standardization, INOR, from Spain, for generate new parameters and new politics based on standards who transmit directly the IoT device in factories via blockchains for assure the data in all the aspects and helping to follow up the different emission and the control the different parameters who is the machines working in the industry in base of different regulation. It depends of the material, and in general the context and the companies who is know this action are totally interesting in these new steps.
Thank you for your time. Okay,
Alicia, thank you very much for your time and your pleasure.
Bye-bye. Ciao.
Bye. Thank you for your time. Ciao.
Last but not least, it's my pleasure to present Sense4Com. The project is a result of a Belgian-Dutch cooperation between BSense, Sonaca, and Sony Solutions. So I give the floor virtually to Christophe Koster of BSense. He realized the demo. Thanks to, we will discover in a very practical way how Sense4Com works.
goal of the Sensorcom project is to equip composite materials with optical fibers. To this aim, the B-Sense company in Belgium teams up with the Somni company in the Netherlands to provide a solution fully integrated in carbon-reinforced composite materials. Our sensors are distributed and embedded during the manufacturing process, and they can afterwards be used during the lifetime of the product to predict the possible appearance of cracks or failures. In the fabrication process, we use a standard telecommunication grade optical fibers and this laser technique to ride fiber back grating inside. So the very first step we need to take is to put the optical fiber in the system so that it can be irradiated by the laser. Our optical fiber sensors are then embedded within the carbon fiber plies at the Sonaca company, and the manufacturing process of the composite materials is made in an autoclave. We have also designed and built an original smart interrogator. You can see an example here in the printed circuit board that allows sending light into the optical fiber and collect the signal for visualization here on a spectrum analyzer. You see the spectra of two gratings that are embedded in the composite material, and if I apply some pressure on the material, you can see that we can follow exactly the strain that has been applied. The added value of our project is the ability to follow in real time the strain profile in composite materials, and this using a smart and cost-effective interrogator. The next steps of the project are clearly to integrate further the smart interrogator and add the communication aspect to get a smart object, and certainly to bring it to the market for aerospace industries. From the fiber to the interrogator, the Sensorcom project brings a full solution to the composite material industries.